the number of mosquitoes in millions, M, so M is the number of mosquitoes in millions, in Brooklyn, New York, it depends on the June rainfall in centimeters. R, so R is the amount of rainfall measured in centimeters, and can be modeled by the function M, so the number of mosquitoes in millions, is equal to negative R times R minus 4, where R, once again, is the rainfall in centimeters, I guess, in June. All right, fair enough. Now let's see if we can answer these questions. And like always, I encourage you to get inspired and try to answer these questions on your own. All right, the first one. How many centimeters of rainfall will there be? After how many centimeters of rainfall will there be a population of 0 million mosquitoes? Or will there be just no mosquitoes, 0 mosquitoes? Well, let's just rewrite this function. So our population of mosquitoes, it actually just helps my brain to rewrite it, to kind of process what's going on. My population of mosquitoes in millions is going to be negative R times R minus 4, where R is the number of the number of centimeters of rainfall. So in order to have a 0 million population, so that means M is going to have to be equal to 0. So we need to figure out at what R's is M equal to 0. So we just have to solve this right over here. Well, in order for this expression right over here to be equal to 0, notice it's a product of two expressions. We are multiplying, you could view it as we're multiplying negative R times R minus 4. Let me do R minus 4 in a different color. Times R minus 4. So if you're multiplying two expressions and you get 0, one or both of them need to be equal to 0. So let's see how that happens. So either negative R is going to be equal to 0, negative R is equal to 0, or you're going to have R minus 4 is equal to 0, or R minus 4 is equal to 0. So how does negative R equal 0? Well, you divide both sides by negative 1 or multiply both sides by negative 1. You get R would need to be equal to 0. How does R minus 4 equal 0? Well, you add 4 to both sides. You see that R would have to be equal to 4. So it either is no rainfall, 0 centimeters of rainfall, or 4 centimeters of rainfall. You get a population of 0 mosquitoes. Now, why does that? Let's just think about whether that makes sense, whether this is a good model for the number of mosquitoes. Well, we always imagine mosquitoes need some standing water. So if you have no rainfall, there's not going to be any place for them to breed. There's not going to be any standing water, maybe. And this way, this model seems, it's like, well, if you have enough rainfall, so some rain is going to help the mosquitoes breed. But then if you have enough rainfall, they're just going to get, I guess, washed out someplace. I guess raindrops are going to hit them as they fly. I don't know what's actually happening at the mosquito scale, but it's implying that if there's a lot of rainfall, it would actually be hard. I guess you don't have standing water anymore. The water is moving around and it's overflowing and it's going into the gutter and whatever else. It would make it very hard for the mosquitoes to breed. What is the maximum possible number of mosquitoes? So the very idea that they're asking us a maximum implies that this quadratic over here, and it is a quadratic, and we'll see that more clearly in a few seconds, is shaped like this in order to have a maximum point. Because if it was shaped like this, it would have a minimum point. It wouldn't have any one maximum. And because we have this negative out here, that makes us pretty confident it is going to be a downward opening parabola. But to understand what this maximum point is, let's write it in vertex form. And just as a reminder what vertex form would be, it would be writing into the form of M is equal to A times R minus B squared plus C. This right over here would be vertex form, and it's very useful because you get a sense of when you hit a minimum or a maximum point. If this thing right over here is negative, then the maximum value, because this thing can only be non-positive, the maximum value would be this, and then we could figure out when does this equal 0, and that's when you hit that maximum value. And if any of this seems foreign, I encourage you to watch the videos on vertex form. And I'm about to complete the square on this character in order to get here, so I encourage you to also watch the videos on completing the square. So let's do that. So let's start with this expression. And I'm going to start by, I'm going to just distribute the R. So if you have M is equal to, I'm going to keep the negative out front, but I'm going to distribute the R. R times R is R squared. R times negative 4 is minus 4R. And I want to complete the square. And once again, I encourage you to watch those videos if what I'm about to do seems like voodoo. But to complete the square, I want to add and subtract the same thing. I don't want to actually change the value of the expression. And so I'll look at this coefficient, this first degree coefficient here. It's negative 4. Half of that is negative 2. If I square it, I want to add 4. I want to I want to add 4. I want to add, excuse me, let me make it a different color. I want to add 4. Now once again, I can't just go around adding numbers to expressions and assuming the equality still holds. I have to add and subtract the same thing. Well, you might be tempted to write a minus 4 out here because, hey, I added 4 and then I subtract 4. But remember, when I add this 4 in this parentheses, I have this negative out front. If I were to distribute this negative, this is a minus 4. So if I wanted to add them out to be 0, distribute this negative, this would be a negative 4. If I wanted to cancel out this needs to be a positive 4. So once again, when you look superficially, it looks like I just added 4 twice, but I didn't. This right over here, since it has this negative sign, is a negative 4. Negative 4 plus 4 is 0. I have not changed the value of this expression. But anyway, now that I've done that, this piece right over here, the whole reason why I added 4 is to make it a perfect square. This is now the same thing as r minus 2 squared. I have the negative out front. We have m equals negative r minus 2 squared plus 4. And just like that, I've written it in vertex form. So what's the maximum number of mosquitoes? Well, let's just look at the structure of this expression a little bit. This piece right over here, that thing, actually, let me not do it in the same color as the 4. Let me do it in this orangish color. This piece right over here is always going to be less than or equal to 0. So that's always going to be less than or equal to 0. It's always going to be non-positive. And so this whole expression hits a maximum value when this thing is 0. Because at any other point, it's going to just take away from this right over here. So you hit a maximum value when this is equal to 0, when negative r minus 2 squared is equal to 0. Well, that's going to happen when, well, you could see when r minus 2 is equal to 0, or when r is equal to 2. And when r is equal to 2, what is m going to be equal to? Well, when r is equal to 2, this is 0, and m is equal to 4. r equals 2, and m is equal to 4. So what's the maximum possible number of mosquitoes? Well, m equals 4. It's going to be 4 million mosquitoes. Remember, m is measuring in millions. 4 million mosquitoes. And then they ask us, after how many centimeters of rainfall will the maximum number of mosquitoes occur? Well, we figured it out. After 2 centimeters, 2 centimeters of rainfall. So if we go back to our model, at 0 rainfall, you have no mosquitoes. Then as it rains more and more, you have more and more mosquitoes. I guess more and more standing water. You have a maximum number of mosquitoes at 2 centimeters of rainfall. At 2 centimeters, we have 4 million mosquitoes. But then after that, I guess the rain starts washing away the mosquito eggs or something. And you start having fewer and fewer mosquitoes all the way until you get to 4 centimeters of rainfall. And I guess after 4 centimeters of rainfall, in theory, you have negative mosquitoes, I guess. I don't know what that would mean. And that might just be a situation where the model just breaks down. You obviously, I don't know what negative million mosquitoes would actually mean. The relevant area where this model should hold is between 0 centimeters of rainfall and 4 centimeters, because after that the model starts describing negative values for m. So anyway, hopefully you found that interesting.